Good morning, children. Today we are going to continue the lesson Unit 4 Factors Part 4 and learn highest common factor. Now we are going to learn highest common factor. What do you mean by highest common factor? The greatest number which divides both the numbers exactly without leaving any remainder is called the highest common factor of these numbers. In short, it is written as HCF. HCF of two or more numbers can be found by any one of the following methods. Method 1. HCF by listing factors. In this method, we list all the factors of the given numbers. From the list, we select the highest common factor. For example, let's find the highest common factor of 15 and 30 by listing the factors. First, we have to find the factors of 15 and 30. Now, with the help of multiplication tables, we can find the factors. So, factors of 15 are 1 15s are 15, 3 5s are 15. So, factors of 15 are 1, 3, 5 and 15. In the same way, let's find the factors of 30. 1 30s are 30, 2 15s are 30, 3 10s are 30, 5 6s are 30. So the factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Next, we have to find the common factors. That means the factors that are common in both the numbers. So common factors of 15 and 30 are 1, 3, 5 and 15. Of these, the highest common factor is 15. So HCF of 15 and 30 is 15. Let's do one more example. Let's find the HCF of 14 and 33 by listing the factors. So first let us find the factors of 14 and 33 with the help of multiplication tables. 1 14s are 14, 2 7s are 14. So factors of 14 are 1, 2, 7 and 14. In the same way, let's find the factors of 33. 1 33s are 33, 3 11s are 33. So factors of 33 are 1, 3, 11 and 33. Next step, we have to find the common factors. The common factor here is only 1. So HCF is 1. Thus, HCF of 14 and 33 is 1. Now children, try these sums. Find the HCF of the following by listing the factors. Method 2. HCF by prime factorization. In this method, we find the prime factors of the given numbers and then list the common prime factors. The product of all the common prime factors will give the HCF. Now let's find the HCF of 12 and 18 using the prime factorization method. First, we will find the prime factors of 12. Now here 12 is a composite number and also an even number. So we can divide 12 by a prime number 2. 2 times 6 is 12. So we have here 6. 6 is an even number and we can again divide by the prime number 2. 2 times 3 is 6. Here we get 3. Now 3 is an odd and prime number 2. So we divide by 3 itself. 3 times 1 is 3. Here we got 1. So our division is complete and we have found all the prime factors of 12. Now let's do the prime factorization of 18. 18 is also an even number. So we can divide 18 by the prime number 2. 2 times 9 is 18. Here we get 9. 9 is an odd number and we can divide by 3, which is a prime number. So 3 times 3 is 9. Here we get 3, which is odd and also prime. So we divide by 3. So 3 times 1 is 3. We got 1 here. So we stop our division. Now what did we do? We found all the prime factors of both the numbers 12 and 18. So now next step is let's find the common prime factors of 12 and 18. So here prime factorization of 12 is 2 into 2 into 3. Prime factorization of 18 is 2 into 3 into 3. And what are the common prime factors? Here you can see it is 2 and 3. So 2 and 3 are the common prime factors of 12 and 18. Now if we multiply these common prime factors, we get HCF. So HCF is 2 times 3 equals 6. Thus HCF of 12 and 18 is 6. Example 2. Find the HCF of 15 and 25 by prime factorization method. Remember, we have to use only prime numbers. First, we will find the prime factorization of 15. Here 15 is divisible by a prime number 3. So 3 times 5 is 15. We have here 5. Since 5 is a prime number, we divide by 5 itself. So 5 times 1 gives 5. Here we got 1, so our division is complete. Now let's find the prime factorization of 25. Here 25 is divisible by a prime number 5. So 5 times 5 is 25. So we have here 5. Since 5 is a prime number, we divide by 5 itself. So 5 times 1 is 5. Here we got 1, so we stop dividing. Next, now let's write down the prime factorization of 15 and 25. Prime factorization of 15 is 3 into 5. Prime factorization of 25 is 5 into 5. Here common prime factor is 5. Therefore, HCF is 5. So, HCF of 15 and 25 is 5. Let's do one more example. Find the HCF of 28 and 33 using prime factorization method. First, let us find the prime factorization of 28. Here, 28 is divisible by either 2 or 7, as both are prime numbers. So, we can take any one of these prime number. So, let's divide 28 by 7. 7 times 4 is 28. We have here 4. Now 4 is again divided by 2. 2 times 2 is 4. We have here 2. Since 2 is a prime number, we divide by 2 itself. So 2 times 1 is 2. Here we got 1. So our division is complete. Now let's find the prime factorization of 33. 33 is divisible by a prime number 3. So 3 times 11 is 33. We have here 11. Since 11 is a prime number, we divide by 11 itself. So 11 times 1 is 11. We got here 1. So our division is complete. Next step, let's write down the prime factorization of 28 and 33. Prime factorization of 28 is 7 into 2 into 2. Prime factorization of 33 is 3 into 11. Here there are no common prime factors. So, in this case, HCF is 1. Thus, HCF of 28 and 33 is 1. Remember, when there are no common prime factors, then HCF is 1. Third method, division by common prime factors. It's very important to keep in mind the prime numbers as we use only prime numbers for division. So let us find the HCF of 12 and 16 by using the method called division by common prime factors. For this, what do we need to do? First, we write the numbers in a row separated by a comma. Next, we divide both the numbers by a common prime factor. So let us see a common prime factor of 12 and 16. 12 and 16 are even numbers and are divisible by a prime number 2. Or we can say 2 is a common factor of both 12 and 16. So let us divide both of them by 2. So 2 times 6 is 12 and 2 times 8 is 16. So here we got the quotient as 6 and 8. Again we need to find a common prime factor of 6 and 8. As you can see, both 6 and 8 are even numbers and are divisible by a prime number 2. Meaning 2 is the common factor of both 6 and 8. So let us divide 6 and 8 by 2. 2 times 3 is 6 and 2 times 4 is 8. Now, can we find the common factors of the quotient 3 and 4? No. So here we stop. So the common prime factors are 2 and 2, which are on the left side of the standing line. So what is the HCF of 12 and 16? It is equal to the product of common prime factors 2 and 2. So we can say HCF of 12 and 16 is 2 into 2 equals 4. That is, HCF of 12 and 16 is 4. Example 2. Find the HCF of 36 and 30. Here first we write the numbers in a row separated by a comma. Next, we divide both the numbers by a common prime factor. Here, you can take either 2 or 3 as both are prime numbers. So let's divide both 36 and 30 by a prime number 3. So 3 times 12 gives 36 and 3 times 10 gives 30. Next, here we have 12 and 10. As you can see, both are even numbers. We can divide by 2. So 2 times 6 gives 12 and 2 times 5 gives 10. Now, can you find the common prime factors of the quotient 6 and 5? No. So here we stop. So the common prime factors are 3 and 2. Therefore, HCF is equal to 3 times 2 equals 6. Thus, HCF of 36 and 30 is 6. Example 3. Find the HCF of 15 and 25. So first we write the numbers in a row separated by a comma. Next, we divide both the numbers by a common prime factor. Here we can divide both 15 and 25 by a prime number 5. So 5 times 3 gives 15 and 5 times 5 gives 25. Now, can you find the common prime factors of the quotient 3 and 5? No. So, the common prime factor here is only 5. Therefore, HCF is 5. Thus, HCF of 15 and 25 is 5. Example 4. Find the HCF of 28 and 33. Here you can see there are no common prime factors for 28 and 33. So in this case, HCF is 1. Thus, HCF of 28 and 33 is 1. Example 5. Find the HCF of 30 and 60. First, we write the numbers in a row separated by a comma. Next, we divide both the numbers by a common prime factor. Here, we can divide both 30 and 60 by a prime number 5. So, 5 times 6 gives 30 and 5 times 12 gives 60. Next, here we have 6 and 12. As both 6 and 12 are even numbers, we can divide both by 2. So, 2 times 3 gives 6 and 2 times 6 gives 12. Again, we can divide 3 and 6 by a prime number 3. So, 3 times 1 gives 3 and 3 times 2 gives 6. Here, can you find the common prime factors of the quotient 1 and 2? No. So, the common prime factors are 5, 2 and 3. So, the HCF is 5 into 2 into 3 equals 30. So, HCF of 30 and 60 is 30. Properties of HCF. The HCF of given numbers cannot be bigger than any one of the numbers. Example, HCF of 4 and 6 is 2. Second property, when there are no common prime factors, then HCF is 1. Example, HCF of 11 and 13 is 1. As you can see, there are no common prime factors between 11 and 13. Example 2, HCF of 4 and 9 is 1. Here also there are no common prime factors for 4 and 9, so HCF is 1. Property 3. If one number is a factor of another number, then the smaller number is the HCF. Example, HCF of 5 and 10 is 5 because 5 is a factor of 10 and of 5 and 10, 5 is the smaller number, so HCF is 5. Example 2. HCF of 6 and 3 is 3 as 3 is a factor of 6. Of the 2, 3 and 6, 3 is smaller, so HCF is 3. Thank you, children.